Hi, I'm Morgan,
I'm Max.
I'm Deven.
I'm Zach.
and this is the Tennis Prosthesis Project. The goal of this project was to design and manufacture a comfortable, lightweight prosthesis that precisely holds and releases a tennis ball. The patient has a congenital birth defect in which the arm is fused at the elbow and tapers to one finger, which can be moved slightly.
The current prosthesis features foam braces that fasten to the patient with a bow system, like snowboard boots. These cuffs have a threaded insert where the current device screws in. This device was made to pitch baseballs, which causes serves to look like this.
Currently, the patient lobs from the waist instead of from eye level like a typical serve. This leads to inaccurate serves. After we met with the patient and had a good understanding of the prosthesis, we needed to get quantifiable data to build a list of specifications or specs to direct our design.
We tested for the consistency of the serve by recording video of the patient serving and tracking the ball as it moved. We tested the force that would be expected to act on the prosthesis by measuring the mass of the prosthesis and recording the acceleration experienced during the serve with a gyroscope built into an Apple Watch.
We also tested the strength of the patient's finger to make sure any device we designed wouldn't overstrain or cause injury to the patient. With the specs we developed from the data, we could finally brainstorm concepts that would embody them. Some were better than others.
We wanted to make a device that allowed the patient to control the release of the ball. We divided concepts into categories based on how effectively they gripped the ball, released the ball, and secured the prosthesis to the patient. After careful consideration of the best ideas, we started to make them a reality.
Designing the model was the most important part of the project. With each new design change, we needed to meet with the patient and make sure that each change left the prosthesis lighter, safer, or more comfortable than before. Through each design change, we also selected materials, did hand calculations, or ran ANSYS stress simulations to ensure the design met our specifications.
When we eventually developed the final product, we needed to make sure the design passed our specs one last time. We tested the design for consistency as well as for durability. Impact testing was one of the particularly fun tests.
Consistency test results showed that the patient's form had noticeably improved, and that the new prosthesis was slightly more consistent than the previous device after only a few weeks of practice. For comparison, the patient had the previous prosthesis for over a year. Our patient is incredible, so with a few more weeks of practice, we expect his serves should look like this.
This was by far the most interesting and study-intensive project we have had to do at Barrand. We would like to thank the patient, Christian Newbert, for his time and practice with the prosthesis. We would also like to thank the Newbert family, Mrs. Carolyn Lind, Dr. Mendes, Innovation Commons staff, our faculty advisor, Dr. Sanei, and our faculty panel of Dr. Hollinger and Dr. Lewis for consultation and services throughout the project.